Hey guys, welcome back to my channel. In today's video, we're going to see how to solve this problem called evaluate Boolean binary tree, right? So you're given the root of a full binary tree with the following properties. Okay, so the tree is binary tree and it's a full binary tree, right? So leaf nodes have either the value 0 or 1, where 0 represents false and 1 represents true. Okay, fine. Non-leaf nodes have either the value 2 or 3. Okay, so 2 represents 0 and 3 represents Boolean AND, right? So the evaluation of a node is as follows. Okay, what is the evaluation? If the node is leaf node, the evaluation is the value of the node. Okay, so if it is 0, it's a false, or if it is 1, it's a true. Okay, fine. Otherwise, evaluate the node's two children and apply the Boolean operation of its value with the children's evaluation. Okay, so the question is very simple, right? And we have to return the Boolean result of evaluating the root node. Okay, so before getting into the question, we just have to discuss about some concepts that are in this problem. These are the points to keep in mind, right? The first one is full binary tree. What is the binary tree? We of course know, all the nodes will be either having one node or two nodes, right? Nodes as in children, right? So what is full binary tree? Full binary tree is a tree in which every node has either 0 or 1 children, right? So let's have an example. Let's say this is a binary tree. This binary tree is having two children, right? This and this, right? This is having 0 children. This is having two children. This is having two children. This is having 0, 0, 0, right? So every node has either 0 or two children. So it's a full binary tree. And let's come to this tree. This node is having two children, 0 children, two children. Oh, here one children, right? So see, this thing is creating a problem. So I cannot call this tree as a full binary tree, right? This is not a full binary tree. And the second point is that all the nodes are either 0, 1, 2 or 3, right? And the leaf nodes will be either 0 or 1, and all the other nodes that are non-leaf nodes, that will be either 2 or 3, right? And we have to take care of one more thing, that these values are having some meaning, right? Are having some meaning. What are the meaning? 0 represents false, 1 represents true, 2 represents logical or operation, and 3 represents logical and operation, right? So let's say this is the tree that is given to us. Root is this thing, right? This 2 is the root. We have to evaluate. How to evaluate? We will just say, bro, left side, whatever value comes in, and from right side, whatever value comes in, we will just do this OR operation, right? So what I'm going to do, I will stand here. I will say, bro, I will do the OR operation, but from the left side, I'm getting 1. What is 1? 1 is actually false. Okay, 1 is not false. 1 should be true, and 0 should be false. Okay, this is right. So basically, see, this root value is evaluating by doing this OR operation with the value that comes from left side and with the value that comes from right side, right? So from left side, I am sending true. So true will be here. So true or what? So I'll go to the right side and I will ask, bro, 3, please give me the value. So 3 will say, bro, I am AND operation. So I will have to do the AND operation from the left side value and from the right side value, right? So this value I will be taking and I will do the AND operation, and then only I can give the answer, right? So what I'm going to do, I will go to 3 and I will say, okay, bro, do your operation. So this false will come here, this true will come here, false and true, this will be giving false, right? So this node, this particular node, this will be returning false. So here true is there, here false is coming. So true or false, this will be giving true, right? So this root node will be returning true. So if you have an observation, what did I do? What did I do? Like I am actually traversing through all these nodes, and I will say, bro, if it is OR operation, get the left side value and get the right side value. Then I will do OR, right? I will do OR, and then I will return the answer, right? I will return the answer. if it is and, then get the left side value, get the right side value. I will do this and operation and then return it, right? Return it. So if it is not or, if it is not and, what can be the possible value? What can be the possible value? It will be either true or false, right? So I will just do this if condition for true and false also. If it is true or if it is 1, I will return true. If it is 0, I will return false, right? So I will just do this, and I will just do this in a recursive way. In a recursive way. So I'm just going to do a DFS, and then I will say, bro, if this node has to do some evaluation, this will go and fetch the value from the left side. If this particular node has to do some evaluation, this will again go and fetch from the left side. And if I got the answer from this side, then I will go to right side and fetch this value, and whatever value is here, I will do the operation and then I will return the answer, right? So which operation should be performed, this will be decided by this if and this if, right? And at the leaf node, it will be either 1 or 0, right? So I will be handling this case through these two if conditions. Okay, so this is the code, and it's a very simple code, right? So what did I say? If the value, if the root's value, if it is 1, I will return that 1. If it is 0, I will return that 0. See, 1 is considered as true, right? See, if I am returning a Boolean value and the Boolean value is 1, that means it's a true. And if it is 0, that means it's a false, right? So if it is either 1 or 0, I will just return that value itself. Or if it is 2, that means I have to do OR operation, right? With whom? With the left part and with the right part. So I will just call the left part here and I will just call the right part here, right? And then I will do this OR operation and then I will simply return it. Else, if it is not 0, if it is not 1, if it is not 2, that means 3 will be the value, right? So if it is 3, then I will just get the left part, I will just get the right part, then I will do this AND operation, then I will return the value, right? So this will be occurring in a recursive way. So coming to the time complexity and space complexity, time complexity will be often what is an number of nodes, right? So it's just the DFS. So DFS, this will go to all the nodes. So it's a of number of nodes, that is of n. And coming to space complexity, it will be of 1 if you consider extra space. But if I'm going for the call stack space, it will be often at the worst case, right? If it is a skew tree, if it is a tree like this, so the depth of the tree, it will be n. What is n? N is the total number of nodes, right? So this recursion call stack will be of size of n, right? So time complexity is of n, space complexity is of n for the recursive call stack. So that's it for the video. If you like the video, hit the like button, subscribe to my channel. Until next time, see ya.